Hello, welcome back to Learn Physics. In today's topic, we are going to continue with our work, energy and power. Okay, in last class we learned till power. So, last video itself I told you a small portion is left out, that is collision. So, today we are going to do that collision. Okay, so what is meant by collision? So what is meant by collision? Collision is the interaction between two particles at which when they are interacting, what is happening? It will be exerting some strong force on each other. So when two objects are colliding each other, it will exert some strong force for a short interval of time. That is called as collision. So collision is the interaction between the two particles and they exert a strong force when it is and for a short interval of time. Interaction between the two particles when they exert a strong during collision. The colliding particles will be exerting a strong force for a short interval of time. Okay, so that is called a collision. There are mainly two types of collisions. Collisions are of two types. They are elastic collision and inelastic collision. So what is meant by this elastic collision? Elastic collision means, see, if there is no loss in kinetic energy after collision. Okay, that is kinetic energy won't be losing anywhere. That is kinetic energy will remain constant. It will be a conserved quantity. Then we can say it is elastic collision. In the case of inelastic collision, there will be some loss in kinetic energy. Kinetic energy will be losing after collision. So this kind of collision is called as inelastic collision. So what is elastic collision? That will be losing, there is no loss in kinetic energy after collision. That is called as elastic collision. Inelastic collision means there will be some loss in kinetic energy after collision. Okay, so other properties of elastic collisions are, see, momentum is a conserved quantity. Linear momentum is conserved. Momentum will be a conserved quantity and total energy also will be a conserved quantity in the case of elastic collision. So kinetic energy will be a conserved quantity. So there is no loss in kinetic energy. So kinetic energy, momentum, total energy, everything will be conserved in the case of elastic collision. If it is inelastic collision, what will happen? There will be some loss in kinetic energy and other properties will remain same, but kinetic energy won't be conserved. But linear momentum will be, linear momentum is conserved. Okay, linear momentum will be a conserved quantity and total energy also will be a conserved quantity. So all these are conserved in the case of inelastic collision. So now we are going to study about the elastic and inelastic collision and what will be the final velocities of these we are considering one situation like that and finding out the elastic and inelastic collision, what will be the final velocities of the objects. Okay, so next we are going to study about collision in one dimension. So one-dimensional collision. One-dimensional collision. So in one-dimensional, what is meant by one-dimensional collision? So tell me what is meant by one-dimensional motion. If the object is moving in a straight line, then we can say it is one-dimensional motion. So what will be one-dimensional collision? After collision, if the object is moving along the same straight line, okay, so an object M1 is here. It's moving with velocity u1 and an object m2 is here. It's moving with velocity u2 and both are colliding each other. u1 greater than u2, you guess, then it will be moving in the straight line. Okay, so and it is colliding with u2, and after collision both are traveling with v1 and this is v2 in the same straight line. If the object is moving in the same straight line, then we will say it is one-dimensional collision or head-on collision. So what is meant by head-on collision? If the object is moving in the same straight line, then we can say it is called a head-on collision or one-dimensional collision. So here now we are going to consider about the inelastic and elastic collisions. So in the first I am going to consider about the inelastic collision. So inelastic collision, in this case, what will be inelastic collision? Momentum conserved and kinetic energy is not conserved. Okay, so in the case of elastic collision, what will be momentum in this case? m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2. Okay, so next we are considering the kinetic energy. This is for momentum. Then kinetic energy, there will be a loss in kinetic energy in the case of inelastic collision, isn't it? So half m1 v1 square plus half m1 m2 v2 square minus half m1 u1 square plus half m2 u2 square. Total kinetic energy after collision minus total kinetic energy before collision, if we are concerned, we will get some quantity because there will be a loss. It is not same. Okay. While finding out the equation like this, the equation will be very complicated. So we are taking one approximation. M2 is at rest. If M2 is at rest, U2 will be equal to 0. Okay, then next we are considering that, see, after collision both are moving with same velocities. m1 and m2 are at same velocity v. So now this equation, how it will be changing? m1 u2 is at rest, isn't it? So m1 u1 is equal to m1 plus m2 into v, because it is both are moving with the same velocity. That is equal to m1 plus m2 into v. So this equation also we can change it as this is equal to v and this also equal to v and this is equal to 0. So how we can change this? Half m1 v1 square plus half m2 v square minus half m1 v1 square. What is our aim? We are going to find out the final velocity. So what we are going to substituting this v1 value from here, we will be getting a value for v. Okay. Now this equation I am writing it as 1 and this equation 2. Okay, now equation 2 will be changing it as, how it will be changing? What is the loss in kinetic energy? That is equal to half m into m1 plus m2 into v square, because v1 and v2 are same v, isn't it? That is a minus half m1 u1 square, because here u2 is 0, isn't it? So that will be equal. Now what we are, this first equation, m1 u1 equals m1 plus m2 into v1. Now, but we don't know what will be the final velocity, right? So instead of v, I can write it as from 1 m1 u1 divided by m1 plus m2. Isn't it? From this equation I can write it as the m1 u1 divided by m1 plus m2 will be equal to v. Now I am going to substitute this value here. Okay, and I'll get it as this equation. I am writing it as 3. Now I am substituting 1 in 3. Okay, so change in kinetic energy, loss in kinetic energy, I am writing it as delta Ke will be equal to half m1 plus m2. Instead of v square, what I can write? m1 square u1 square divided by m1 plus m2 the whole square minus half m1 u1 square. 1 m1 plus m2 and 1 m1 plus m2 will get cancelled. I will get it as, so I am changing this equation, equals half into m1 square m1 u1 square. I am taking it outside. From these equations, half m1 u1 square I am taking it outside. So I will get the rest of the things as m1 divided by m1 plus m2 minus 1. So while solving, I am rubbing this also. Half m1 u1 square into m1 minus m1 minus m2 divided by m1 plus m2. So m1 and m2 will get cancelled. I will get it as minus half m1 m2 u1 square divided by m1 plus m2. That means what we understood from this, change in kinetic energy will be more in, see, it is a negative quantity while we are taking the final kinetic energy minus initial kinetic energy. Kinetic energy, loss in kinetic energy, how we found out? Final minus initial will be a negative quantity we got. So that means initial kinetic energy will be greater than the final kinetic energy after collision. In the case of inelastic collision, after collision we will be getting a kinetic energy less than the initial kinetic energy. Okay, so that is called a inelastic collision. So you understood how we derived. First we take the momentum is concerned, change in kinetic energy, final minus initial we took. Then we considered the second object who is at rest, and after collision both the objects are moving with the same velocities. Then we wrote it like, and from the momentum equation we got one equation for final velocity, because we don't know what is the final velocity, but initial velocity we can calculate, isn't it? So that one we calculated, and the change in kinetic energy we got it as a negative term, that is minus half into m1 m2 divided by m1 plus m2 into u1 square. Okay, so it is a yes, this is a negative term which we got here. So that one understood that kinetic energy initial will be greater than the final kinetic energy. Okay, so clear for this. Now we are going to consider in one-dimensional collision itself what will be the collision, how we will be considering the elastic collision. Now we consider the inelastic collision, right? Now we are going to consider the elastic collision. Okay. Next is elastic collision. So in the case of elastic collision also, we are considering momentum is concerned. M1, U1, M1 is moving with U1, M2 at rest, and the objects are moving with velocities. After collision, the velocities are v1 and v2 respectively. For m1 it is v1 and m2 it is v2. Okay, now we are going to consider. So in elastic collision, momentum is a conserved quantity and kinetic energy also conserved quantity. So m1 u1 will be equal to m1 v1 plus m2 v2. Okay, then kinetic energy, how we can write down? Half m1 u1 square will be equal to, u2 is at rest, isn't it? So half m1 v1 square plus half m2 v2 square. So how we can write down? See, half, 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 and all get cancelled. So m1 u1 square equals half m1 v, half is not there, m1 v1 square plus m2 v2 square. Okay, now what we are going to do? See here, this equation I will write it as m1 into u1 square minus v1 square equals m2 into v2 square. Okay, this one I am writing it as equation number 1 and this one equation number 2. Now I can write it as equation number 1 will become m1 into u1 minus v1 equals m2 into v2. This one I am writing it as equation number 3. Now dividing 2 and 3. I will get it as 2 divided by 3 will give you, see, u1 square minus v1 square, I can write it as, yes, u1 plus v1 into u1 minus v1. So m1, u1 minus v1 will get cancelled. So here which one will be existing? u1 plus v1 will be existing here. That will be equal to m2 will get cancelled, v2 will be existing. Okay, now first we are going to find out the value of v1. So instead of v2 we can substitute it as u1 plus v1. So equation number 4. Okay, substituting equation number 4 in 1. So 4 in 1. What we will get? m1 u1 is equal to m1 v1 plus m2 into u1 plus v1. Okay, so here I can write it as m1 into u1. So our aim is to find out the value of v1. So v1 terms we can write it as together. So m1 u1 minus m2 u1 is equal to m2 v1. This is v1, right? Minus plus m1 v1. Now I can write it as m1 minus m2 into u1 is equal to m1 plus m2 into v1. So what is the first velocity? Is equal to m1 minus m2 divided by m1 plus m2 into u1. Okay, so this is the first velocity. Then same way we can find out the second velocity also. How we can find out the second velocity? Second velocity we can find out using the formula from 4. We can write it as v1 is equal to v2 minus u1. So this one we will substitute in this one and we'll be finding out the value of v2 in the same way. So you will get v2 as 2m1 u1 divided by m1. So these are the two velocity terms. So now you can see, understood how the derivation is. Actually derivation is very easy, nothing to worry. See, very only simple calculations are there. So now we need these two equations, v1 and v2. Okay, so in the case of v1 and v2, now I am considering those equations. Okay, so v1 equals m1 minus m2 divided by m1 plus m2 into u1, and v2 equals 2m1 into u1 divided by m1 plus m2. So what will happen if m1 is equal to m2? First case, if m1 is equal to m2, what will happen? v1 will become 0 and v2 will be existing with 2m1 divided by u1 divided by 2m1. m1 is equal to m2, isn't it? So 2m1. So what is the meaning of that? If both the objects are same, then find first object will come to rest and the second object will be starting with the same velocity of the initial one. So m1 is moving with velocity u1 and here it is at rest. Then after collision, what will happen? M1 will come to rest position and M2 will start moving with velocity u1. Okay, so understood, this is what happening in the case of if M1 is equal to M2. Next we are going to consider if M1 is greater than M2. M1 is very much greater than M2, what we will consider? See, M2 is negligibly small, so we can neglect M2. What will happen? V1 will be equal to U1, and what will happen? V2 will be equal to U1, to U1. Okay, because see, M1 is very much greater than M2, so we will neglect M2. M1 by M2 will be V1 by U1, V1 will be equal to U1, and here M2 we will neglect. So what will happen? So it will, M1 and M will cancel, so V2 will be equal to 2U1. So after collision, what will happen? First one will be continuing with the same velocity, but the second one is moving with double the velocity of the initial one. Okay, so clear now what will happen? So next is third one. If M2 is very much greater than M1, what will happen? We can neglect M1. So what will happen? See, M1 will be, V1 will become equal to minus U1. That is, it is moving with the, come back with the same velocity. The object will be coming back with the same velocity. V1 equals minus U1. So if it is going with a 4 meter per second, it will come back with a minus 4 meter per second. Okay, so what will be V2 here? V2 here, M2 we can consider, and M1 will get cancelled. So no need of considering M1. Okay, so 2U1 divided by M2, that will be the velocity of M2. Okay, so understood what will happen if, so, and M2 is a very high quantity, so V2 will be nearly equal to 0. So understood what is how we are doing all these one-dimensional collision and its interpretation. So these three cases are very important. Clear for you? So I hope all of you understood all those things, and if you like the channel, please don't forget to subscribe and like. Okay, thank you for watching. Bye.